Right, okay, so let's take a look. I'll just use a standard approach. So we've got solid mechanics. I'll go stationary for this. Yes, what I'll do is I'll set up a beam, basic beam, and I'll just do the normal process here. So let's do L, and we'll make it, I don't know, 500 mil. Length. I always tend to keep them separate. Even if you're doing something that is equal, I've always kept them separate just in case you change your mind. So I'll stick on. I'll obviously need a driving element, so I'll give it a force of, let's go 500 newtons. Not massive. Right. And I am moving pretty swift in this for anybody who may be following me. I'm moving pretty swift just because we've done quite a bit of this type of approach. So I'll just do let's do a work plane from an XY plane, and then from there let's just do this go W, and that will be H. Build. So 50 by 50 coming from the lower corner, and then on that I'll just add an extrude, and then that extrude obviously becomes L, and build. And again, this is just to look at this is just for the benefit of the recording really. This is just to look at different parametric approaches and trying to nest different methods. So what we'll do is I'll just stick on a standard material. I'll go with just a normal built-in, makes life easier. At least I know it's all sitting in there then. So as ever, structural steel. Shoot. Oh, my visualization, I've turned it off. Damn it. Let me come back. Let me grab you, and then that's it. Bring that back. Right, let's see if that'll, yeah, that should be fine now. Now I got that all back. Right, materials, settings onto 1, yeah. And then, again, I'll just do a bend on it, but then we can do variance. I'll do a total force, put it in Y, minus F. And then I'll do a fixed constraint on the other side. Obviously, given this geometry, it's not the most sophisticated, so I'll just make it something a bit more sexy, like that. Really, I could do with turning that into quadrilaterals, because obviously it's a beam. And then right, so now what we're talking about here is not the gradual force application, are we? So we're not doing the parametric build of force, so we're not using para and having that iteration coming on that way. What we're talking about here is forces and then different lengths based on the forces. So I right click on there, I've got parametric sweep. So you'll see here I've got specific combinations, I've got all combinations, or I've got parametric switches. If I go into parametric switches, you've got to switch what the case is, what the number is, how you want it to jump in between. So that's how you can have them quite heavily related. Specific combination, or we can just go all combinations. So if I went specific combination, for example, and I put in there for length, and then obviously with this you kind of look and go, well, what are you going to start with? Now on here we started with 500 millimeters, so I'll do that. I'll come on, and then what I'll do is I will start on with 100 mil. And where do I want to stop? Let's go 600 mil, and then what's the iterations between it? I'll go 50, and I'll add that in. What I can do with this now is add another one in, and then on that, oh, well, let's not do it on that, let's do variations of forces. And what this will do is, you see how we've got these combinations, these are specifics, but if I go all, what it will do is run them all in both variants. So if I then go on here and then go number to values, damn, what do we start with? I think it was 150, wasn't it? 500. So if I then run that, and then I won't go step, I'll go number of values, so I'll start with 500. Oh no, I'll start with 100. I will maybe go step, so 100, and we're going to stop at 600. Oh, look how original I am, my god. Let's stop at 800, and we'll do iterations of, I don't want to do one that's absolutely gigantic because this will take forever to go through different combinations. I will do the same iterations of so I'll add that, and now we've got both parameters in there. We can go specifics, or we can go all possible combinations. And solutions, the trouble is when you run these through, you can end up with so many different possible combinations that you might want to only say what the last ones were giving you. I don't know why you've, well, I mean, there is some cases where you would. So what I'll do is run that. And I'm hoping, because I chose a different shite, just realised something. It's actually meters, isn't it? Damn it, damn it, damn it. So, hang on, let me see if I can convert that. Yeah, look, I've gone 100 meters to 600 meters. Yeah, that didn't work out well. Can I actually simply? Right, so now what it's in essence doing is running through all possible combinations that I've set. Trouble is, I've set an awful lot of different combinations, and you can see that it's at 3%, which is great that it's done it, but it's still running quite a few yet. Let me pause the recording because nobody wants to just sit there and watch something computing. Yeah, so as some of you will find as you download stuff from things like GrabCAD, it visually looks very good. And then you look and go, that motorbike's only 5mm long or something like that. So you do need to just double check the model, make sure it's something realistic. And the reason I'm stressing this out there is because when you import this, and it's an important thing for you to report actually in the assignment. Tell me how big these things are. Because often when you open something, in fact, I have just had a research paper verified and ready to be submitted. And you won't believe it. I forgot to put a scale on one of my drawings. And in fact, I will show you this. And one of the moderators for this piece of work actually came back and went, "You've not told us how big it is." And I kept thinking to myself, my God, students would eat me alive with this one. But it was absolutely true. So just to give you an idea of how important it is, let me just quickly show you this. So this is one that I've been working on with some of your course leaders, and so let me just open this up when it opens up. So this is one that I've been working on with some of your course leaders, and you'll notice one of the big things I did wrong. Where is it? There we go. There's no scale. They don't know how big that is. And yeah, I got they came back and went, "That's great and everything, we love what you've done, but we don't know how big it is." So I kept thinking, my God, students would assassinate me with that. So yes, do make sure that you put on some level of scale just to say how big it is. I knew you'd have a question. I need to pause this. Just to finalise, yeah, thank you, Joel. I'm just turning that back on now, just because with this, I wanted to get that pretty much done. In fact, I wasn't recording when I was taking, I don't like to name, so when I was taking said person through PubMed, so I'm probably going to do that again, just because I think any of you are medically based or interested in bridging to the amazing world of human to machine interfacing like that, or human to assistive technologies like that, you might be interested. Anyway, after numerous amounts of time, this solution has now been completed. This is the overall parametric suite. You can see a single study solution there, so I can isolate to the single study, but I actually want the whole parametric approach. Now, there is tons and tons of stuff that we can get out of this, and I know it's just a beam. So I can look at what was happening when it's at a single, when the length was at 0.1 and it's 100 newtons. So if I go plot, that's what we get. So, but what if I wanted to look at it at 800 newtons? Go plot, and all it does is just spikes it higher, as you'd imagine. But I can do that in every single possible combination. Or I can move around, I can set it to that type, and it will give me what happens in that state. Now, I know what you're thinking. You don't want to have to sit here clicking again, click here, click there, go next. You just don't want to be messing around with things like that, and it can be frustrating. I totally get that. So, let me just bring that back. This just shows where your loading is, that's all. So what you might want to do is you might want a comparative. Now, when you're running comparatives, you've got all your data here. You've got this monster amount of data. What I'm actually going to do is use a 1D plot. Now, with a 1D plot, it's basically a graph. So what do I want to do? Let's consider the stress above and the stress beneath. So the stress in tension and compression. And let's look at the difference between it. So I'm going to go plot and let's go line. Now with this, all it says here is tell me a point that you're interested in. Now we've already said I want the top. I want the full top here, and then when I come back, I'm going to get the bottom one. What can be a common thing is people put both on. on the same. So if I did both here, it kind of goes, whoa, 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 whoa. Which one do you want? So you choose one at a time. Now I like to rename these labels, so I'll call this top stress. And I'm obviously, for my display here, I'm going to change that now and then turn that into solid mechanics. Come to stress, and I will go von Mises. I can go shear, can go normal. I mean, really, if we were calculating through verification, we'd need to go normal stress. If we're going von Mises, we're comparing against the ultimate tensile stress of whatever the material is. So that's just to spell out the differences that we get in there. So I go plot. That's what it gives me, as you'd imagine. Now you kind of go, okay, but what exactly is it that we're looking at there? If I go back to my 1D plot, look here, see how it's gone? That is the static solution. So that's the single run of this. I kind of go, whoa, I don't want that. I want the parametric sweep. Now, I'm going to plot every combination in one plot. And this is why you need to be careful when you're moving forward. So if I go plot, and it will look like a 5-year-old's scribble book, because it's just going to throw everything in there. And just for anybody's information, when I normally run these, I don't normally set specifics. I normally run it all, and then afterwards choose what data I want to use and what data I'm just going to get rid of. Because it's like taking pictures. You take hundreds of pictures, and then with it, you often pull out the golden ones. And that's how I've normally operated. So this was my point. That is every possible combination for length and force. You can see there what it's got it named it as arc length. I don't like having it like that, so I will call that beam length. Plot. There we go. So you get the beam length of it, and then you've got the von Mises in comparative to what's happening. And the good thing is here you can see the steps. So you can literally see where these are all originating from. So let's say, for argument's sake, in fact, I've not brought on the other one yet. So let's say I want to do the bottom one. Now this process here I do quite like. So what I'm going to do is right click, and I'm going to duplicate. Wait for it. Give it a minute. Give it a minute. Because basically what it's doing is gathering all the data again. Now there's a reason I'm duplicating. Because all I'm going to simply do is change the position that I'm taking this from. So you see that I've got top stress 1, and I just call this now bottom stress. And when I say onto that, click on here, get rid of that, put it onto the bottom one, and then click plot. Now again, still, it's a mess. I get that it's a mess. You look and go, yeah, I'm still not impressed. And I totally understand that. So with your plots, with your output, your graphs that you're producing from this, you kind of go, which way's the best way to do this? When it plots, of course. So at the moment, what I'm using is the main graph here where it says 1D plot group. That is controlling the groups. I can change that. So if I go up to here, if you remember, I've controlled it from here. However, what if you want to use all of one, but on the other you only want a couple? So if you come onto here, you say, where is the data set coming from? You can go from parent, which is the 1D plot group, or I can go from here, and I can individually choose how that's going to be displayed. For this plot, I like them both being controlled in a way, because there's a few things I want else to show you. So then, let's say in our lengths, you kind of go, I don't want to show the lengths. So what I'll do is perhaps I'm just going to choose from a list. I'll start at 0.1 and 0.6. And then we'll go, I don't know, 2.25 and then plot. So what it now does is isolates them down. So this now only looks at specific lengths. This will now thin down, but the trouble is the bottom stress. Apologies, not the bottom stress. The length is still apologies. The force is still varied to all. So this is the result of all the forces being running on these particular lengths. And these are the results that you're getting from it. But again, you might not want to see that. You might just want to see what happens on the last force running at these lengths. So if I click plot on that, that is the result of the last force running on these key particular lengths. And then from there, there's all types of extra things that you can do with this. So let's just simplify this down a little bit so I can just show you a little bit more. So I'm just going to set that to last. So now it's just both last and last. So it's a last scenario, and that's what we keep getting now. If I zoom into there, you can see there. So we've got upper stress and lower stress. So we've got the top and the bottom of this, and that's what we're getting. So I can just isolate that down and just disable that and plot. Oh, apologies. So disable and plot. That is the output from the top. So we can do an awful lot with this. We can do an awful lot with this. You can also set up multiple graphs on it. So let's say this is stress, and we want also to have displacement on the same graph. This gets this is I'm just going to call this as really what it is. So this is extra. This is not something that I'm expecting you to also get on here as well. See here where I've got two y-axes. I'll click on two y-axes. And what I'm going to do here is do something different. So if I go my second y-axis, what is it going to be? I'm going to call this bottom stress. So what you'll see though is you'll go, well, still the same. Just plot down. So it's still the same, but this is where it gets really juicy. So let's say now what I wanted is stress and displacement. So if I go solid mechanics, go displacement, and for this, let's just go total magnitude of displacement. I'm going to also relate this back to the original onto here, and then we go plot. That is stress and displacement of the actual component. Tells us an awful lot about what's going on. So you've got the beam length, you've got how much is deflected, and the stress that's in it. There is, by running parametric sweeps, you've got a mountain, an absolute mountain of data that you can pull from it. There's all types of things you can put on it. You don't need to just have two plots on here. You can have multiple plots on here. You don't even have to use lines. So what I could do, this is when it gets really overcomplicated, I think. I think you can go too much. I do really think you can go too much. I've now used what's called a point. And if I click onto here and then go plot, you kind of go, where's that? That's displacement. So if I go to stress, and all this will do is just measure. Well, it's actually just coming from the point of where it's originated. So it's up here. So it really, sometimes you can just put too much on there, so that really doesn't work. I've personally always used lines. just find it really useful. So let's say from my list now, I mean, if I did all, it would just, I'll show you how it turns out if we do all for both combinations. As you can imagine, we've got stress, variant to length. This will be displacement, variant to length, but it just kind of shows how much monstrous amount of data that you've got on here. Takes it time to plot it out. I'm going to pause that because it'll just take its second. It's all a little bit messy. I totally get that. So again, I'll just bring these back to something. Let's say we're going to go first. So that's the first, how it looks in the first displacement. Very short length and with a very low force applied. So let's say we want this graph and we want this to be used. So there's a few ways you could do it. You could simply go image snapshot, where on this image snapshot you can say what do you want to take a photo of. I can take a photo of the current way, or I can set it up for presentation, or whatever I really want to do with it. How do you want to export it? I always go JPEG, just nice and straightforward. File target type, you can put it into PowerPoint, wherever you want. How big do you want? I always go 30. I'll show you why in a moment. I always go 30 because when you put these in, the numbers are so tiny. You kind of go, who can ever see that? I never put titles in. Now, this isn't just because I'm trying to say don't put titles in. I just don't put titles in, that's all. So, and I'll browse where I want to put it. So I'll go on the desktop and I'll just say save, and then I'll go OK. So if I go down, and then go onto the desktop. That's too big, definitely too big. So if I'm not happy with it, I can simply just go back and I can just do it again. So if I take another snapshot, I'll go down to 12. I do want to replace it. Let's have a go. That looks a bit better. But you can see there, that as an output is dead slick. You present something like that in a report, it is dead slick. It really does spell out exactly what you want to. I mean, depending on what it is that you're doing. Now, the last thing I wanted to show you on that is making sure that your font's right, or making sure it's how you want it. Now, you'll come down here, see under graphics, we've got color themes. You go, oh yeah, dead sexy. Come into here, and then, more interestingly, we have family, and we also have size. So if I go family, I'm always a stippler. Well, you don't have to for your assignment, by the way, but I always like to have it in Times Roman. It's just me. So you can set default sizing for that. So if I go 10, or if I go 20, if I go 16, 16 is not so bad for this. Because the thing is if I do a snapshot of that anyway, it's going to ask me how big do I want it to be, so I'll still put it on 12. So if I output that and then step onto here, and you look and go, yeah. So these are just little ways of outputting from particular results, because the trouble is if you run a parametric sweep and you ended up with, well, I mean, what did we actually end up with there? We ended up with a lot of different possible variations from that set of results. So just from there, so with 15 on there, yeah, 30. Yeah, so we've ended up with an awful lot of combinations that can come out of there. So, about 15 squared, really, isn't it? And capturing that in a single slot can be incredibly difficult. If it was me to actually do something like this, I would probably take a snapshot of this in one hit. So I'd probably take a snapshot of that, and I'll just call this something else. Stress. So I'd probably take a snapshot of that. Then what I would end up doing is putting this into something like Word. So put that into Word, and then you kind of go, right, you know, you explain what it is that's going on, and then from there I would then come down, and then obviously explain what's going on, and then you move into the bigger data sets. So then you bring that in, and then what you end up doing is it just flows really nice. So then you're saying this is how the result looks, but this is a collective of all different variations that I was looking at, and it just flows really nicely. It kind of tells the story pretty well of what you're doing. If it's used to anyone, I wasn't sure that I was going to actually need to save it, but if it's used to anyone, I'll probably save this if you wish, and I can upload this to Teams. At least then you guys do have a reference to it. So I'll save it and just call it Beam. The only thing I could have really done, I should have really done, is just done a bit of a verification. So good way with this, it's beam theory, so I could put that into here, and then I could output a plot of normal stress just to give me some verification, and then move on to this variant. So this static, we could have a separate static on there for that reason. Right, so let me just minimize that. As I said, I will upload this so you guys can see it. Now, the other question I did want to come back to was I had some questions about importing of geometry into ANSYS. It was a great question, and I just wanted to quickly cover over it. So if I go onto a static structural and bring in static structural as normal, and for my geometry, I'm going to right click on geometry, I'm going to go to import geometry, browse, and all I'm going to do is, all I'm going to do is bring in my spine segment. This was the original segment that I had opened in SolidWorks, so I'm going to bring that in, and just get rid of that. So I'm going to bring that in, and as ever, when it comes in with a review file. So it's just saying review what you've got. So if I go, now I've always used Design Modeler. I've started to just try and get used to Space Claim, but for this I'm not going to touch Space Claim because I don't want to add any further confusion. Well, no, I don't want to add confusion, I should say. Oh, sorry. So I'll let this import any minute now. Oh, there we go. And you see there we've got lightning bolts, so let's just generate that geometry. Right, now it comes in looking like this. This is what they call frozen. Now it's just because I'm actually not going to edit the component. I'm going to presume that the geometry that was brought in is correct. All I need to be sure is that the model that's been completed is a model that I've got usable. Now I only say this because when you first import it, it can be a bit intimidating because you look and go, well, is there something wrong with it? It's transparent. That's all that it is. So I say this just to reassure anybody who's been doing it, don't worry, you're doing it right. Only thing you do need to check is up here I've got part one body. Extend it, you see there how it's like a little cube, like a little ice cube. So if I click onto it, you see there, that is just telling me it is recognized as a solid piece. Tells me how many vertices we've got, how many faces, how many edges. And if you are keen to actually make this, to promote this into ANSYS to be something modeled or changeable, there is some things you can do. So in concept, in tools, I can go to unfreeze. So if I go unfreeze, it then says what bodies do you want to unfreeze? I want to unfreeze this body. Click apply. Click apply. There we go. And then click generate. And what you'll see is now it's been converted to a model that can be converted and changed. Now, one thing that I did learn, which is quite interesting, if I it's just for your information. You see how I've had to go through that process. One thing that I did learn, that with something like Space Claim, and this is why people have been, in a lack of better words, losing their bits over it, because in Space Claim, what Space Claim will do is it does away with all that messing around and unfreezing and freezing and doing all sorts to it. Space Claim, all that does is it tries to bring it in like a normal geometric modeler. Anybody who's CAD savvy, and I know there are a few on this call who are CAD savvy, you'll know that it's still not at a CAD level, but it's what it is really. It's we work with what we got. I'm just waiting for Space Claim to load actually. Let's come back into this. I'll get rid of this. Here we go. So that's what it does now. Now it captures that body and then starts to bring it in. And it's a good bit of kit. As I said, I've been learning a little bit interesting things from it. So you see there, it's bringing in that, and it's just completing that initial process. Process complete. So now what it does, it brings it in. Now the beauty in this, if I come into this now, again, I'm not wanting to confuse things with this, but you look now, this geometry is now usable. It's not in that frozen state. So it doesn't really matter, and it doesn't really matter if it is or it isn't. I can actually do all sorts with this now, and it just does away with it. And it gives a few little extra bits and bobs to allow you to repair if there is any major damage. Now in this case there isn't any major damage in the geometry, but sometimes, it's like there can be, very easily be. And I just really wanted to show this to some of you in particular because of that. So again, do not panic. You've not done anything wrong. Everything is working as it should. It's just the system itself, that's all. So again, if I then go from here and then go into my simulation side, so I'll go into my simulation, I don't know, environment or world, whatever you want to call it. And give it a minute. Any minute now. I sometimes think this is my PC that's just taking its time. Right. So you look there. Now when it comes into here, this is a big thing, because you'll notice when you bring the geometry in, that frozen state that the part was in the modeling environment now doesn't exist, and it's just that. What it's actually, all the transparency is just really saying to you in Design Modeler is, I am still in a state that you can't edit me, but if you want to edit me, you've got to unfreeze me, and that's all that is. And what Space Claim does is Space Claim brings it in and says, right, I put it into this state. You can edit here, but when you take me out, you won't be able to edit. You've just got to simulate, but you can bring it back. And it's just a way of solving it. That's all. So that's just to reassure anyone who did panic when you first saw it. Right. So I'm just going to pause there, and what I'm going to do is something different. Now this is something totally different. This is coming from a different perspective entirely. This is coming from the other side. This is using the Comsol Matlab interface. Now I do know some of you do have this, so I wanted to show it you. And normally when you double click in, this is what you get. It runs in DOS, and what it now does is it will grab your Comsol that's on your PC and also grab your Matlab. Now when you first do this, you've got to choose a user interface, you've got to choose a password. And I normally have the same user interface and password, but I normally remove that need for password just because No one else uses my PC but me. And so now what it'll do is it'll go straight into Matlab. Now what it's actually doing in the background, it's actually running Comsol solvers in the background. Now I'm not going to do any key simulation with this. What I want to do is just take you through how to interface with this, because it is incredibly powerful, really powerful. We'll do some basic things just in this, because I know that we're on nearly half past. For the next 15 minutes we'll just do some basic things, show you a little bit way for navigation and having a look at what's going on. I often forget, there's many different little bits of plot things on here, very useful, but I often forget different things. So, runs in, goes, oh, welcome to Comsol and Matlab, you go, happy days. So, this is non-intuitive. Hell, it's Matlab, it's never intuitive. So, what we want to be able to do is we want to be able to move around. We want to be able to see what in the hell we've got going on. So, there's a few things you can do. Let's just use some of the basic ones for a start, and then I'll take you a little bit further down the rabbit hole. This is quite cool. Application. These are all brand new, by the way. So application library. Basically, it's saying here, just type it. So if I what this does is MPH. I mean, when I first got into this, I kind of looked and thought, what in the hell is MPH? MPH is the back reference file type to Comsol. That's all that it is. And we've got libraries that run on the back side. Now, if you look here, these are brand new. These, and by the way, these are absolutely mint. These are really useful. So we've got tutorials built into these systems. Now I'm not going to do something like that. I'm just going to go on to something that's already been created. So I'm going to go mph open. And all this will do now is it'll bring up a list. And it goes, right, what files do you want to open? These are former files that I've run. Now just as a nice connection, I'm going to browse to the beam. And then click open. And wait for it. Now what this does is it doesn't look like it's doing anything. In fact, it looks bloody useless. What it's actually doing is it's accessed the library and it's now looking actually in the folder. See where the chevrons came back? That confirms that the model's now activated and I can do things in this model. So if I'm unsure what to actually write, if I type help, what this will do now is this now goes into information and it tells me a list of things I can do. You go, ooh, list of things, nice. So I'm going to cheat here just because I can't be bothered to wait. What we're going to plot. Oh, that's a good one. Right, so see how we've got MPH plot? Got MPH plot. It says MPH plot model PG1. Basically, it's going to plot the first thing that it can find on that list if it's there. So if I click on enter, it plots that. And as ever, as you can imagine, you can navigate around the model. You can add more plots to this, and that's what I think I'd like to go through you guys with. So some of you I do know would like to be able to do more things like that. So what else we got on this list? We've got MPH open, saves. Now I'm going to take you through a couple more bits on this because it is dead cool stuff. So let's have a look. MPH mesh. So if you look here, MPH mesh. So that tells me that if I go use that, but this time rather than plot, I'm going to go, let me get this right. I always get this one wrong every single time. Let me pull that back. And there we go. I can now pull the mesh. Now, the reason that we put these into Matlab is, let's say you wanted to control every single variations of that mesh. This you can do. Let's say for example you want to use sim multibody. You wanted values going on, and you wanted to be able to use them values to calculate your stress all in one go. You can do that doing this. So what you've then got is a possibility for a very complex dynamic system that you can pass data backwards and forwards to get the most realistic. This is a heavily multi-physics approach. If you're interested in all different types of so non-Newtonian materials, and you're wanting to dynamically look at a non-Newtonian material moving whilst it's being meshed, this is how you can do it. So there's some crazy amounts of things we can do. So let's just go back again. Let's go. I think there's a plot 3. So you see that. Now with this, if I wanted to do things, what I can do is go onto my plots. And then from my plot here, I can set the font, I can set key elements to it. So let's go times. And then let's go something like, I think I set it to 16. And then what we've got is another way of outputting it. So if I put that to there, something like that. I often get rid of titles, so I'm just going to cut that. And if I plot that, save as, let's make this, I'll make this as just a JPEG to show you what I mean. It's that bit like that. And you look, it looks very slick. So this is the type of thing you can do, and as I said, I don't intend to put this in your, I don't expect this to be in your assignment at all. I just thought you might think this is a little bit extra and something else that you might be interested in looking at. The one thing that I've not shown you yet, and I will be showing you, is how to control it. So how to run. Now, I quite like that the parametric side was brought up dead early in this session, which is very useful for me because it gives me a lot of justification to say, well, right, let's look at a parametric process in different conditions, different conditional states, and we can do that doing it this way. Again, that was just to show you a little bit around using it, so I can go. Where is, I always forget the model command. So under here we've got yes, there, MPH geometry, that one. So you can go there and that will just drag in the original geometry. And that's, with that scale, that's often quite useful to be able to just put in for your dimensions or for a reference to sizing. You can do subplots. As I said, I think I might do a little bit more of an in-depth session about controlling it through Matlab, because there's crazy amounts of stuff you can do, and me just quickly going through it this way doesn't really do it its entire justice, because we can control parametric changes, we can do all sorts with it. Right, so I don't intend to do any more on that, or else I'm going to end up getting people very annoyed.